Welcome to Ask and Learn.
Okay, the question is asking us to find the number c that satisfies the conclusion of the mean value theorem on the given interval. And then it asks us to graph the function, the secant line through the endpoints, and the tangent line at cf of c. And it's asking us, are the secant line and tangent line parallel? Okay, so there are two conditions required for the mean value theorem. One is it has to be continuous on the closed interval from 0 to 4, the function, and the function has to be differentiable from 0 to 4 on the open interval from 0 to 4. So, recall the graph of the square root of x looks something like this. It looks like a curve, something like that, and it is defined at 0. So we know it is continuous on 0 to 4, and you can also take the derivative of any point along this function, so we also know it's differentiable. And now we are going to be finding the number c that satisfies the conclusion. And so remember, the conclusion of the mean value theorem states that there is some c such that the derivative of the function, the point c in the derivative of the function gives us the average slope, which is f of 4, which you can simply find by just doing f of 4 minus f of 0 all over 4 minus 0. And now we can solve for this right away. So recall that the square root of x can be rewritten as x to the 1/2. This can allow us to take the derivative much more easily. So the derivative, well, we're going to be writing it in terms of c, which will give us 1 over 2 root c. And that is equal to, now we plug in the values, so the square root of 4 minus the square root of 0 all over 4. And the square root of 4 is simply 2. And the square root of 0 is 0. And so it leaves us with 2 over 4, which is the same as 1/2. And by just looking at this, you can see that a c of 1 will satisfy this equation. So c is equal to 1. And now we are being asked to find the actual equation of the line that is being produced here. So we'll do that. We'll just do this on the next page. So the way you can do this is you do this through the point slope formula. So in this case, we want to find the tangent line at this point. So at f of c, and then we know the slope, which is 1/2. So we'll put that in, and then x minus c, because that is the actual x point. So y minus, and so recall that our c value was 1. We had a c equals 1. So when you plug in our f of x was root x, and so we can plug it in. We can plug in 1 for this function. So the square root of 1 is just 1. So we're going to put square root of 1. Our slope we found was 1/2. And then since our c is 1, we can also write x minus 1. And then we can rearrange this equation, and it will give us y equals 1/2 x plus 1/2. So this is the equation for the tangent line on the graph. Now we're going to find the secant line. So the secant line is also very similar. All we have to do is same exact things, point slope formula. It'll be y minus f of 0. And then we calculate the slope. And the first point is, we're just using 0, 0 as our 1 point, because in the point slope formula you can use either point. So for this simplicity case, we're just going to use 0, 0. Since that is on our interval, recall that And the slope actually is calculated by just doing y2 minus y1. And since our interval is root 4 to 0, 0 to 4, we just do y2, which is root 4, minus y0, all over 4 minus 1, and 4 minus 0. And this just gives us 1/2, and we already knew that. And f of 0, square root of 0 is 0, so this is just 0, and this is also 0, so we can just rewrite this as y equals 1/2 x. And if you look at these two formulas, they have the exact same slope, except the tangent line, it just shifted by a factor of, shifted up by 1/2. So what does this mean on this graph? Well, all it means is that from 0 to 4, so let's just say this is 4, this is what it looks like. This is the slope. And then at the value of 1, let's just, the 1 is right here. This equation right here, this line, is just, it's the, so this is the y equals 1/2 x, and then this is y equals 1/2 x plus 1/2. And this is the one that's tangent. And so the question here is, are the secant line and tangent line parallel? And yes, they are, because they have, again, remember, the same slope. So they have the same slope, which is m equals 1/2, but just one of them is just translated up.